Hello everyone, I'm Ragip Akbas. I am from Özyeğin University and this is a joint work with my research assistant Sevde Baltasi. She just got her master's degree from Istanbul Technical University. So this talk is about pre-construction alternatives. That's an area where there is a significant lack of automation. And the idea here is using BIM and resource integrated simulation, making it a bit more structured and ability to analyze in a more structured way, in a more quantitative way, different alternatives. That's been pretty lacking in the industry. So the problem is there are lots of decisions made early during pre-construction stages, and they have obviously large impact on project costs, right? Before construction, the decisions you make, you cannot change later on. If you want to change them, it's very costly. However, these decisions are made by really smart, experienced people in companies, but they rely on experience and they rely on experts. And each company have different experts, they have different experience, and depending on who is there at the moment and who makes those selections, you have different results. They might not be optimal, right? Typically, they are not analyzed and they are said, okay, this guy worked on a similar project like this, so good, let's go ahead with this. Once you make that decision, you are stuck with it, right? You make your schedule based on it, you make your estimate, and the other possible alternatives, which can be better, are completely forgotten, right? So again, these are typically made pretty well, and companies, that's the core competency of companies, but they could be made in much better way, and they could be remembered in the future for the future projects, right? So what does technology help? How does technology help us for this, right? There is increased use of BIM for estimating and planning. So there is 4D, 5D, bunch of quantitative of estimating tools. But do they help us in terms of analyzing those alternatives? And what we have seen so far, actually Sevde made her master's thesis on this, and what we've seen so far on pretty complex, pretty large projects is, again, even if they use BIM, even if they have full BIM design models, these decisions still rely on experience of some guy. And we are particularly focusing on resource-related alternatives. There's obviously many different decisions that's made for projects, but before bidding and during pre-construction stage, important decisions related to resources. There is some automation techniques, but they are limited, right? You cannot really simulate the whole construction project and analyze, compare different alternatives in terms of time and cost and utilization and different factors. So primarily, it's hard to evaluate crew, equipment, construction method, sequence alternatives, for time and cost for the overall project. Right. Typically, during pre-bid stage, companies have very limited time, and they don't really have time to analyze different alternatives. So they pick one and they go ahead. And during pre-construction, you don't want to change too much your alternatives, and you make your picks based on whatever you pick. These alternatives, right? So if we have a project like our test case that has two separate buildings like this, right? There is pretty much different alternatives you can consider in terms of should the project use mobile cranes or tower cranes? And what's the quantity? How many of each? What type can we use, right? How many cranes is ideal for the project? Also the location. And there's a bunch of research related to location of tower cranes, but again, they typically don't consider the whole project schedule and costs when making these decisions. Should we construct both of these buildings in parallel, or should we do the first one and the second after the second? How many total crews are there for each trade. How many do you want to use? Do you want to use a fixed amount for the whole project, or do you want to increase over time? And how do you want to allocate those crews to different activities? And we also have an option of the number of crews that can work on an activity. Do we want multiple crews working on certain activities, or do we want just one? Typically, we assume one activity working for one crew working for one activity, right? And typically, what we are trying to decide is the flow of the project, right? How would the different crews flow over the project and complete work in many different sequences for building projects. So the current practice is, again, experts are the ones who are making these decisions based on experience. And schedules are made based on these early decisions, and also at the same time, estimating is prepared based on this, right? And there is lots of visualization tools out there. Once you make your schedule, and once you make your estimate, you can show the results pretty nicely using 4D, 5D models. You can see how costs change over time and how the schedule works. And you can detect the issues over that, but you're not actually comparing different alternatives pretty well. And there are too many alternatives to consider at once. So our method here is discrete simulation, and it's actually hybrid simulation. But the typical use of simulation in construction is, the traditional one is, especially in research, is making the simulation and, if possible, visualize the results of BIM, right? BIM and the simulation environment is typically completely separate. And there's lots of research for resource optimization, right? You can perform simulation and try to figure out what's the optimal number of resources we can use. Now the problem with that is it doesn't consider the whole spatial configuration of the project. It typically relies on the construction schedule, which may not be too accurate in the first place, and it actually, that schedule is dependent on many decisions that you make on resources. So it should be an iterative process where you can change many factors at once. And there's much of research that can generate simulation models from BIM, and they actually started from 1990s. For example, the CIPROS research from 1990s generated from product models, simulation models. But again, typically they are cumbersome and they don't rely on the spatial information available on the 3D models. And it's very hard to compare, generate and compare. Generating alternatives is not that hard, but comparing them and making them consistent is very hard. So the research aim is to define a simple automated method, right, for structured comparison of resource alternatives directly on BIM models. So you analyze, you simulate and get the results directly on BIM, right? And provide quick and easy ways to compare these alternatives. Try different alternatives and see which one works better for our purposes. So to do this, this is a platform that I've developed. This is called JC3. It is a hybrid agent and discrete event simulation platform, and it analyzes the construction process as a whole on BIM models. Okay, so the 3D BIM elements are direct part of the simulation, and all activities and resources are direct on BIM. Okay, so it kind of looks like 4D models, but it's not. It's actually what's happening behind is everything is simulated, and you see the results, but those are the results of the simulation. Okay, resources are integrated in this platform. Okay, every crew and equipment are individually part of the simulation, and they behave as agents. Once they get assigned to activities, they behave as agents to perform work, crews and equipment. So you can define their behavior and they are part of the simulation. Okay? And at the same time, typical activity networks as CPM and work balancing like location-based scheduling is supported in here, right? So it's compatible with typical workflow of construction professionals. So the basic JC3 workflow is starting with importing BIM and activity networks in a simulation platform. Again, it's kind of similar to 4D models you get in a basic activity network and BIM, but in GCMX you generate something called location flows, which are the basic simulation entities. And they are related to each other and basically simulated together, right? You define the resources, their properties, and assignments to activities, and in the end you simulate and analyze results. You can easily change any parameter here and simulate again. And the overall perspective for GCMX is you have a bunch of location flows, they are related to each other, and under each location flow you have multiple activities. Under each activity you have one or multiple servers, which can support multiple crews. So if you want to have multiple crews working on an activity, you may have 2 servers. Okay? And these servers are assigned locations so they are assigned available. So there's a resource pool, different types of resource pools. Whenever the activity is able to start, they get assigned certain whatever is necessary for equipment and labor. And these crew agents start performing work and start processing these locations. And in the background, what's happening is there are queuing networks, and those queuing networks are simulated altogether. So for this particular research, we are interested in pre-construction cost alternatives, right? So we want to get detailed cost calculation for resources. Here, the resources are individually represented, and their usage may vary. It's not fixed, typically fixed as in most traditional CPM approach. And sharing resources is possible. So you can actually share the same crane for multiple activities, so the crane can support multiple activities at the same time. So here the important part is how do you calculate the cost of crews, right? Is as if the crew is not working, do you actually pay for them? Right? So there are decisions that has to be made about so if the crew is idle for a couple of days or 1 week, do you actually pay for that crew? So there's a bunch we made certain choices at this point. For this particular test case, what we are doing is if a crew is working a particular day for certain hours, it's paid for that amount. For equipment, we do something like if they work for a month, if whatever month they're working, if they are rented, they are paid the rental amount for that month. So you can actually define these decisions within simulation to calculate the costs. And we also say there's a fixed daily rate for indirect costs. And we give simple ways to compare different alternatives once you create the simulation. And our assumption here is there's no design change for this particular example, which means material cost is not that relevant for us. The main cost for us is cost of the resources. So this is a simple test case. We have 2 office buildings, and the base case says we are focusing on reinforced concrete and architectural elements. Okay, and in the base case, we assume there are 4 crews for each main trade except concrete, and you can either have a shared tower crane or mobile cranes, and we have different alternatives to compare. So let me show you a quick demo for this. Okay, so this is a simulation environment. We got all the activities and resources in. Now when you say simulate, it's starting to simulate everything, and what you're seeing is actually the result of the simulation dynamically, right? It's currently being simulated in the background, and costs are accumulated and time passes, right? So you can see that all the individual small guys represent 1 crew, okay? And you kind of also see the mobile crane. It's where it's actually working. They are agents, so they actually know they can only work when they are available and close to the activity. Okay? So the whole construction process is being simulated right now. You can see there are 2 mobile cranes in this example. There may be some problems where the crane gets inside the model, but don't worry about that. That's some minor thing. So basically, the simulation is complete right now, right? So you can actually look at the cost performance over time. And you can also look at the crew use over time, right? How many crews are used for different types of trades. Same thing for equipment. So in this case, for example, mobile crane is used later in the project for 2 mobile cranes. You can also get information about the overall simulation, right? What's the total cost, total duration, the utilization of each individual resource, and cost for each individual. Actually, you can, if you don't show the display for simulation, it only takes less than a second to simulate the whole thing. Okay, so you can easily calculate many different alternatives. So it's going back, and you can see that it's actually being you can see the results of simulation. But less than a second for each individual test case. Okay, so you can easily compare many different alternatives. And to change any alternative, you can add a crew directly in the UI. Similarly, you can add or remove different equipment. But the easier way is to create simulation scenarios. So change number of carpenter crews from 1 to 4 and try all of them, right? So in this case, when you say show all runs, you can see how the costs change over time for different alternatives. Okay? And similarly for crew views. In case 0, there's only 1 crew. In case 3, there is 3 crews. So you can see how that changes. So you can compare very easily, right? And similarly, you can compare the results for simulation summary. You get the information for all those 3 cases. Okay. Okay, so a very quick show of how you can also have, again, the crane may look a bit silly, but the behavior is correct. So it can actually only access locations where it can reach. Okay, it's an agent, and in this case, you have 2 crews for each activity, and there's a crane and there's multiple. So the duration in this case is much shorter than the other test case. So in the interest of time, let me go to the summary. So the total duration and cost for alternatives. So we basically created these different charts. We created these in Excel, but it's very easy to create in the software. You can compare different alternatives for 1 mobile crane, 2 mobile cranes, 3 mobile cranes, 1 mobile crane and 2 crews per activity, 2 mobile cranes, 2 crews per activity. So different resource alternatives, how project duration changes, and how total costs change for these alternatives. So you can easily pick which alternative suits best for your project. And again, each simulation takes less than a second. And ideally, I mean, you can individually try them, but it's very easy to compare all of the alternatives at once. You can automate this process very easily. And similarly, you can do sensitivity analysis, right? What's the effect of change of number of crews on total duration and total cost? So you can see if it actually changes the cost of the project if you add or remove 1 crew. And you can make your decisions based on it, right? If it's not important to increase it, again, get rid of it and then think about it later, okay? And in conclusion, the idea here is to create an effective early stage alternative evaluation using BIM and realistic resources, which is significantly lacking in our current environment. And to provide a structured initial approach to easily evaluate time and cost results for major resource decisions early in the project. Typical problem in current projects is you have, again, the expert knows a lot, but it's really hard to consider all of the factors at once, right? Once you change one factor, it affects something else. So it's really, if you don't consider them as a whole, it's really hard to get the good result. And early results, this is one of the early topics of the general application of GCMX, but this is a general purpose simulation tool on BIM. And there's a bunch of potentials for this for optimization and stochastic analysis. Right now, the simulation that I showed you is deterministic, but you can easily make it stochastic. It actually internally works stochastically too. And it's open to many optimizations where you can pick the best, this computer can pick the best alternative by itself. So, thank you.